Okay, so in this video I'll be doing 3.2, section 3.2, and I'll be doing question 17 and 18 and any random top question. So I'll just quickly get started here. Question 17 here states fx is equal to 24 radical x cubed minus 11. Now I should remember that when there's this binomial here controlled by an exponent that is, not really a whole number, or it's kind of greater than 1. In this case over here, it's x power 3 minus 11 all to the power of half. What we have to do here is the chain rule, where we do the derivative. Wait, so that means the derivative of fx is equal to, let's say we call this inside over here, x cubed minus 11 equals u. Now I'll just do u prime is equal to 3x2. Okay, so now we have to do, and then we'll just, of course, leave the outside as a constant. So I'll just do 24 and the outside completely, we'll leave it outside, and then we'll just focus on the inside. So, and then we have to do kind of, I don't know how to explain this, but we have to do, in a way, like, you have to do derivative of this whole entire thing, like it's only one term. So we'll do like u1 and so minus 1, and then we do 1 over 2. It's weird, but that's how it is. And then multiplied by u prime. So let's solve this now. So once I put it into picture, you'll understand what I mean. So u value inside the u is x cubed minus 11 power of minus half multiplied by u prime. So u prime here is 3x squared. And then I just simplify this here. So I get 3x squared over 2x cubed minus 11 half 24. And then I cancel. And I get this simplified here. And now they're asking, so now this is f prime x, and now they're asking for like the value of the derivative at x equals 3. So now we just do the same thing here, f prime, and now we substitute x with 3. So okay, so I've simplified everything, and now I just, on the calculator I put it, I got 81. So now I know that f prime 3 is equal to 81. So the answer here is 81. Okay, now question 18. Given that fx is equal to 3x squared over 1 plus x, what whole number is equal to f prime minus 2? Now here we have to use the chain rule again. First we'll bring this binomial back to the numerator. So we have 3x squared 1 plus x power of minus 1. And now we'll apply the chain rule. We'll use the same rule we used in the previous question. We'll just do we have to use actually a mix of u prime and also, no, actually even easier, we can just do alone the v prime is equal, when vx is equal to u over v, we can do v prime x is equal to u prime v minus v prime u over v squared, with u being equal to 3x squared and v equal to 1 plus x. So now we'll do just that. U prime, now we just find each value separately. U is equal to 3x squared, u prime is equal to 6x, v is equal to x plus 1, v prime is equal to 1. Now we substitute and we get so 6x multiplied by v, which is x plus 1, minus v prime u is just 3x squared, and then over x plus 1 squared. I simplify. And then over here I can get 3, wait, and now I can substitute from here. From here I get this, and then I can just substitute the value f, wait, so this is f prime x. Now I'll just do f prime, the 2 is unclear here, it's 2. Now I'll do f prime x, and we set x to minus 2. Remember, we're at this question, by the way. So we do 3 minus 2 to the power of 2 plus 6 multiplied by minus 2 over minus 2 plus 1 to the power of 2, and we get 12 minus 12, 0. Wait, double checking for 12, yeah, 0. So that's it. I did minus 1 here, I'm so sorry. It makes no sense here. This is just a prime. Okay, so here f prime minus 2 is equal to 0. Okay, so I'll do a more common one. Question 22 as a top question. Why they gave us here that y is equal to 3 minus 15 over 2x plus 3. Now here are the following questions that they ask us. Now first, to give us information, they state here that there is a normal, what do they call it? They just give us the normal to the curve A crosses the, okay, so this is the normal here. I guess we can call it L. I don't know. So over here, the first question asks for the equation of the normal. Now first we have to get the equation of the tangent. In order to do that, we must do y prime, and y prime, I guess, will be equal to, we just discard the constant. We have to use the chain rule here, so wait, let me just rearrange this first. And then I can derive. No, actually, and then I have to bring this up, so then, or I can do the, no, it's way better to do the chain rule, so I'll bring it up. But it's entirely up to you. You can use the quotient rule or the chain rule. I personally prefer the quotient rule. Okay, now, sorry, I personally prefer the chain rule. But okay, so I do this, multiplied by 2, and this is a constant, so it's just gonna be 0. So I have 32x plus 3 minus 2 is equal to y prime. Now they're stating that they have the normal at A, which is a line AC, but it kind of expands forever, but whatever. We'll call this line L. Okay, and at line L, there's one point A, where such that A is intersecting the curve, and it's also the x-intercept, like the same point as the x-intercept of the curve. So what we do, we get the x-intercept of the curve. In order to do that, we have to set y equal to 0. So first let's do y equals 0 here. So now we have 0 is equal to 3 minus 15 over 2x plus 3. We just want to get the full coordinates. Okay, and then what we do, we get 3 is equal to 15 over 2x plus 3. So that means 6x plus 9 is equal to 15. And that means x is equal to 1. So now that we have x equals 1, now we have the full coordinates. It's 1, 0, and x-intercept. We know that coordinate is A. And we can call this the, I guess you can call it the y0, sorry, x0, y0. Okay, now we have the slope of the normal. We'll go back to the gradient, the derivative of y. And what we'll do, we'll plug in this x coordinate so that we can get the slope of the tangent. So you do y prime is equal to 30, and then 2, 1, plus 3 minus 2, so you get 5. Okay, so that means you get 3 over 25 is equal to tangent, or slope of tangent. And you know that slope of tangent multiplied by slope of normal gives you -1, which means that, in other words, 30 over 25's reciprocal multiplied by minus gives you minus 25 over 30. And now we can simplify it here. We were able to simplify it previously, but I decided to simplify here because it doesn't matter. As long as you have a simplified answer at the end, you get minus 5 over 6 as mn. Okay, now we'll just apply this back into the rule. Y minus y0 is equal to mn x minus x0. We have y0, x0. So we put y0 as, 0. And then mn, which is minus 5 over 6. And then x minus 1. Now we distribute. They wanted us to write the formula like this. So we'll just quickly rewrite it. We'll multiply all sides by 6. So you get 6 minus 5x plus 5. And then I rearranged it so that I move this side over there, move it there. 5x plus 6y is equal to 5. For of course, the formula of the normal at x equals the x coordinate of a. Anyway, so now we have to find the length of BC. How do we get the length of BC? We have to find the y-intercept of the normal and the y-intercept of the curve. What is the y-intercept of the normal first? That's way easier to get. What we do here is y-intercept is when x is equal to 0, so now we just have 6y is equal to 5. So y is equal to 5 over 6. So the coordinates of C is 5 over 6, 0, 5 over 6 for C. And now to get the B coordinate, we must put x equals 0 in the formula. So we just get 3 minus 5, which is minus 2. So the coordinates here, there is 0, minus 2. So over here, it will be 0, minus 2. And over here, it will be 0, 5 over 6. It is off scale, I know, but this is not me making this. Actually, it might not be, but I don't really care. Honestly, we have to do it the methodically correct way. And now we apply the distance formula. In this case, it's all on one axis, so you don't really have to apply it. Just make the y back to positive. So you have distance between this and this. To do this, we'll just, you can literally just do y2 minus y1 squared plus x2 minus x1 squared radical. However, you can literally put this in absolute values. You just get 2, and then you just have to add, and you have to just get the, whatever, we'll use the formula and we'll see here. But you can, I'm pretty sure you can literally just add them up. Let's substitute here. You have y2, y1. So we'll just get, for example, I don't know, 2 minus 5 over 6 squared, and then radical. So you get 17 over 6, the distance between them. So if we want to represent x, if we want to show it here, we can do -2 minus 5 over 6 squared plus 0 minus 0 squared. This will be equal to 17 over 6. This is the distance. And if you want to be more specific in your answer, and it's always safer to do so, say 17 over 6 units. Okay, so I'll be doing my final question, question 25. However, this time I'll just be using entirely this side, since now the space. So question A, they give us first graph, y is equal to 7 plus 3x minus x squared. they want us to prove that this is the formula for the curve, for the like line of normal at x equals 2 on the curve, on the parabola of this. So what we do, first we have to derive, we get 3 minus 2x, and then we get the derivative at x equals 2 here. So we get the gradient at x equals 2 here, so 3 minus 2 by 2, you get minus 1 is equal to the slope of tangent. We just do reciprocal of minus 1 multiplied by minus, you get 1 is equal to mn. You apply it into y minus y0 is equal to mn x minus x0. y0 x0 is given to us right here. x0 is 2, y0 is 9, right? Yes. And mn is just 1. We'll just isolate y like they want us to. Get y equals x minus 2 plus 9, which is equal to y, which is all equal to y equals x plus 7 as the formula of the normal. So given that the normal meets the coordinate axis at point A, when they say coordinate axis, they mean y and x intercepts. Now let's look here. Given that, okay, so coordinate axis, we'll just get this, we'll find the y and x intercept when y is equal to 0 and when x is equal to 0. So let's get the x-intercept when y is equal to 0. 0 is equal to x plus 7. X is equal to minus 7. So minus 7, 0 is 1 point on the coordinate axes. And then x is equal to 0 in another case. So y is equal to 7. So 0, 7. These are our two coordinates, coordinates on the coordinate axes. Now they want us to find the midpoint. What we do is x2, okay, so I wrote down the formula to get the midpoint between these two here. I want to assume it's built like this, where over here it's minus 7, 0, and over here it's 0, 7. So we have this line just built here, and we want to find this length here, sorry, the just midpoint. So what we do is, we just have to get minus 3, you have to do minus 7 plus 0 over 2, and then 7 plus 0 over 2, you get minus 3.5, and then 3.5. But I'm sure they would like it if you use it in decimal form. So minus 7 over 2 and 7 over 2 is good. It's also a correct answer. So for this, the answer here, it's minus 7 over 2, 7 over 2. So the coordinates, so find the coordinates of the point at which the normal meets the curve again. So that means you have to find the two intersection points of the curve and the normal. So we'll just put them equal to each other. We'll do y equals y. So we have both y's here. Okay, so now we'll just isolate 0. So we'll do x squared minus 2x. Wait, these cancel. Let me rewrite this. Minus x squared minus 2x is equal to 0. X is equal to x minus 2 equals 0. The points of intersection with the normal and the curve is x equals 0 and x equals 2. One point is already given, x equals 2 here, so you have to just get we have to pick x equals 0. So we don't know the exact name of this, I guess we can call it j. And now we just have to find the y of this coordinate, and to do that we can plug it into any two formulas, this one or this one. We pick the easier one. They're both easy. You get 7. So j is 0, 7. You don't label it as j, but just keep it for temporary use, and then at the end as your answer put 0.7, since you're now finding here another x-intercept, I guess. No, wait. Yeah, not another. It's not a y x-intercept. It's a y-intercept. So yes, this is the answer here. And yes, that is it for 3.2. And I'll continue doing the videos until I reach chapter 5, or another word with like integration. So yeah, see you in the next video.